Right, before we go a single step further, let me take four things off your shoulders. You do not need a degree in mathematics to learn machine learning. You do not need to be good at calculus. You do not need an expensive computer with a graphics card in it. And you certainly do not need to be 22 years old. What you need is a laptop with a web browser, 2 hours of honest instruction, and the willingness to type code you don't fully understand yet, and keep typing it until you do. Welcome to AI and Machine Learning from Absolute Zero, brought to you by CloudNimbus. 8 parts, about 2 hours, and by the end of it, you will have built something real. My name is Rohan Singh. For the last 12 years, I've worked in cloud architecture and infrastructure automation, the unglamorous plumbing that keeps large systems running, and more recently in AI and automation. In that time, I've trained close to 1,000 students across the globe, and I want to be honest with you about something I've learned from every single one of them. Almost nobody fails at this because it's too hard. They fail because they never find out what's actually required, so they spend 11 months on Python tutorials preparing for a starting line they can't see. This series exists to show you the starting line, walk you across it, and keep going until you've shipped something. Here's the deal. 8 parts. Today, part 1, you'll train your first model in about 6 lines of code in this video with me. Part 2 is your complete setup and the honest prerequisite list. Part 3 is the 20% of Python that machine learning actually uses. Part 4 is data, and that's where our real project starts. Because from part 4 onward, we work on one continuous problem. 7,043 real customer records from a telecoms company, and the question every business on Earth wants answered: which of these customers is about to leave? Part 5 is how machines actually learn, taught by building the maths yourself. Part 6 is the professional workflow, the pipelines and the traps that separate a hobby project from real work. Part 7 is neural networks and modern AI, large language models, embeddings, and what people mean when they say RAG. And Part 8, we take that churn predictor, tune it, turn it into a web app, put it on the internet, and hand you a link you can put in front of a recruiter. That's the promise. 6 trained models, 1 cleaned real-world dataset, and a deployed application, starting from zero. Now, how to actually use these videos, because this only works one way. Watch a section, pause, type the code yourself, not copy and paste, type it, because your fingers learn things your eyes don't. Then break it on purpose. Change a number, delete a line, see what the error says. Every part has homework at the end, and the homework is where the learning actually happens. The video is just the demonstration. And when something doesn't work, and it will not work repeatedly, that is not a sign you're bad at this. That is the job. Professional engineers spend most of their day with something broken in front of them. The difference between them and a beginner isn't that their code works first time. It's that they've learned to read the error message calmly instead of closing the laptop. So let's get the central idea straight, because almost everything else follows from it. In ordinary programming, you write the rules. In machine learning, you show examples, and the machine works out the rules for itself. Take spam filtering. The old way, a programmer sits down and writes rules by hand. If the subject line contains the word free, add 10 points. If it contains winner, add 15. Unknown sender, add 5. Over a certain score, it's spam. And that works for about a fortnight. Then the spammers write F.R.E.E with full stops between the letters, and every rule you wrote is worthless. So you write more rules, and more, forever. The machine learning way. You take 100,000 emails that humans have already labeled. This one is spam, this one isn't, and you hand the whole pile to an algorithm. You never tell it what to look for. It finds the patterns itself, including patterns no human would have thought to write down. And when the spammers change tactics, you don't rewrite anything. You feed it newer examples and it relearns. That's the shift. Examples in, rules out, instead of rules in, answers out. Every single thing in the next 7 parts is a variation on that sentence. And while we're being precise, what is a model physically? It's simpler than the word suggests. A model is a function, something you put numbers into and get a number out of, with a set of adjustable dials inside it. Training means turning those dials automatically over and over until the function's output matches the examples you gave it. That's all. When you hear that a large language model has 400 billion parameters, that means 400 billion dials, turned by exactly the same process you'll write by hand yourself in part 5. So there's no magic in the box. There's arithmetic in the box, done very fast, an enormous number of times. Now the vocabulary, because 4 words get used interchangeably by people who should know better, and they are not the same thing. Artificial intelligence is the big outer circle. It's the whole ambition of getting machines to do things that seem to need intelligence. It's a goal, not a technique. Machine learning sits inside it, the specific approach we just described, learning patterns from data. This is where most of the actual work is, and it's where parts 1 through 6 of this series live. Deep learning sits inside machine learning. Same idea, but using neural networks with many layers, which turn out to be extraordinarily good at messy, unstructured things. Images, audio, language. That's part 7. And generative AI, the chatbots, the image generators, the large language models, is a corner of deep learning that produces new content rather than sorting existing content. Also part 7. So when somebody says, I want to learn AI, what they almost always mean is that second circle. And that's good news, because the second circle is the most learnable, the most useful in a job, and it runs perfectly well on the laptop you already own. Before we touch a keyboard, let me demolish 4 beliefs that keep people stuck at the starting line for years. Myth 1, you need advanced mathematics. You need to read mathematics without panicking, which is a completely different skill from doing mathematics. In practical work, you will almost never derive anything. You'll need 4 ideas: what an average and a spread tell you, what a vector and a matrix are, what a derivative means in plain English, and roughly how probability behaves. 4 ideas, not a degree. Part 2 tells you exactly how deep to go. Myth 2, you need a powerful computer. You need a browser. Google Colab gives you a free machine in the cloud with a proper graphics processor attached if you want one, and everything in parts 1 to 4 runs there. Your laptop's job is to display a web page. Myth 3, you must master Python first. You need about 20% of Python. Variables, lists, dictionaries, loops, functions, imports. That's around 25 hours of study, not a year, and part 3 teaches exactly that slice and nothing else. Myth 4, you have to build the algorithms yourself. You don't, and you shouldn't. Almost every model you'll ever ship is one line from a library that thousands of experts have already optimized. The skill that gets you hired is knowing which model to reach for, preparing the data honestly, and being able to tell whether a result is real or whether you've fooled yourself. That last one is genuinely the job, and it's most of part 6. And there's a 5th one that people rarely say out loud, so let me say it for you. It's too late, everyone else started earlier, and the field has moved on without me. Here's the honest response. The fundamentals in this series, how a model learns, how to split data honestly, how to tell a real result from a flattering one, have not changed in 20 years and will not change in the next 20. The tools on top of them change constantly, and everybody, including people who have been doing this for a decade, is relearning that top layer all the time. So the gap between you and them is not as wide as it looks from where you're standing. It's just the fundamentals, and that's what we're about to do. Right, hands on keyboards. Open a browser and go to colab.research.google.com. Sign in with any Google account and click New Notebook. What you're looking at is a notebook, a page made of cells. You type code into a cell, press Shift and Enter together, and Google runs it on a machine in a data center and shows you the result underneath. Nothing installs on your computer. Nothing can break. If it all goes wrong, runtime, restart and run all and you're back. First cell. Import Seaborn, load the Penguins dataset and call head on it. Shift and Enter. There's your data, and this is real data. 344 actual penguins measured at Palmer Station in Antarctica. Each row is one bird. The columns are its species, the island, the length and depth of its bill in millimeters, its flipper length, its body mass, and its sex. Our job, hand the machine the measurements and have it tell us the species. Nobody writes a rule about flipper length. We show it examples. Second cell, drop the incomplete rows. Real data has holes in it. 2 penguins are missing measurements. 11 have no recorded sex. Today, we simply drop them, and we're left with 333. In part 4, we'll handle missing data properly, because dropping it is usually the lazy answer. Third cell, 2 variables. Capital X is the 4 measurement columns. Lowercase y is the species column. Learn those 2 letters now, because you'll see them for the rest of your career. Capital X is the features, what the model is allowed to look at. Lowercase y is the label, the answer we want out. Features in, label out. Fourth cell, and this is the single most important idea in the whole series. We split the data, 80% to train on, 20% held back. Why hold anything back? Because if I test the model on the same penguins it learned from, I'm asking it to recite, not to think. Any model can memorize. So we seal 67 penguins in an envelope, and the model never sees them during training. That envelope is the only honest measure of whether it learned anything at all. Beginners skip this, get 99%, and post it online. We're not going to be those people. Fifth cell, import the random forest classifier, create one, and call fit on the training data. Shift and enter. That's training, that's the whole thing. Under the bonnet, it just grew 100 decision trees, each asking yes or no questions about the measurements, and they'll vote on every future penguin. It took under a second. Sixth cell, score it on the sealed envelope. 0.97, 97%. On 67 penguins it had never seen, it got 65 right and 2 wrong. You have just trained a working machine learning model, and it took 6 lines. One more. Let's invent a penguin that doesn't exist. Bill 46 millimeters long, 15 deep, flipper 220, mass 4,800 grams. Ask the model to predict. It says Gentoo, and when we ask for the probabilities, it's completely confident. It has never seen that bird. Nobody wrote a rule. It worked it out from examples. And here's my favorite part, you can ask it why. Print the feature importances. Bill length 42%, flipper length 31, bill depth 19, body mass 8. The model is telling you that bills and flippers carry nearly all the signal, and how heavy the bird is barely matters, which is exactly what the marine biologists will tell you. You didn't know that 15 minutes ago. Your model just told you. That is not a black box. That's a collaborator. So what do you actually own now? 4 things. The core idea, examples in, rules out. The vocabulary, AI, machine learning, deep learning, generative AI, and which is which. The 2 letters, capital X and lowercase y. And the sealed envelope, which is the difference between an honest result and a lie. Homework, and please actually do it, because watching is not learning. 1. Rerun today's lab using only 2 of the 4 measurements and see how far the accuracy falls. 2. Break it on purpose. Delete the train test split, train and test on exactly the same data, and watch it report a suspiciously perfect score. That's what fooling yourself looks like, and you need to be able to spot it on site. 3. Put your accuracy number in the comments so I know you ran it. The notebook is linked below, and there's a written handbook for the whole series alongside it, the glossary, the cheat sheets, and a 30-day plan. Part 2 is your complete setup, the honest prerequisite list with real hours attached, and we build your professional environment properly, both in the browser and on your own machine. Subscribe so it finds you, and if you'd rather work through all of this as a structured course with graded exercises, the full guided path is on Udemy through CloudNimbus. Everything's linked below. You trained a model today. You're not a beginner anymore. I'm Rohan Singh, this has been CloudNimbus, and I'll see you in part 2.